So this is the same for sine and cosine. The only difference is with our differentiating, you just need to take a wee bit of care in terms sometimes they don't always put brackets in, so it's maybe not as easy to spot. So for instance, this first one, sine 3x, sometimes they just write it as so, and you'd need to introduce the bracket, okay? So when we're differentiating, all of this is on your formula sheet, remember, but if we're differentiating sine, we go down the way, so it goes to cos. So dy by dx, right, sine when it goes to cos, so it's going to be cos of 3x, then we look inside our bracket, differentiate it, we get a 3. 3x goes to 3, so 3 cos 3x, and that'll be you. Okay, f dash of x is c negative s negative c. Cos goes to negative sine. So we're going to have f dash of x is negative sine of the bracket. Okay, look inside the bracket. I'll squeeze it under here. Right, pi over 4 is a number, it disappears. If you differentiate that, you get negative 2. So, tidying this up, 2 negatives make a positive. So it's 2 sine pi over 4 minus 2x. Okay, and that's us for the second one. Right, next one, we have sine of x squared. Sine goes to cos, did that one in part A. However, look inside your bracket. 2x. Okay, now comparing part C and part D, what we had is sine x squared, so the x was getting squared, so that was fine, but this one we have sine squared x. Now the key to this, that means sine x all squared, so I'm going to have to write it like that. This is going to change the game a wee bit because now we have everything to a power. Okay, so last time it was like sine of something, so that went to cos of something. But we have this whole thing to a power of 2. So applying your rules of differentiation, your 2 is going to come down. Oops. Going to decrease your power. But again, we need to look inside the bracket. What do you get if you differentiate sine? You get cos x. So in fact, we have 2 sine x, power of 1, don't need to put that in, cos x. Now you eagle-eyed folk might spot that we have seen that before. Good thing to know is that 2 sine x cos x is on your formula sheet. It's actually the same as sine 2x. Not necessary, but you know, it's good if you spot it. So we things like that, sine squared x is neater, right? Mathematically, we tend to write it like that. We just like it better. But actually it means sine x all squared. So when you're differentiating it, you need to write it like that so you can bring your power down. Right, in a context, find the equation of the tangent to sine 2x, where x is pi over 3. Now, we know equation of a tangent means differentiation. Okay, in an exam, we have to know what that means. So, we have sine 2x. So, we're going to differentiate dy by dx. Sine goes to cos. Look inside your bracket. Derivative is 2. Okay, so that is our dy by dx. We know that x is pi over 3. Remember what we're trying to do? We're trying to get our x is pi over 6. We're trying to get the gradient, remember. Two times pi over 6 is pi over 3 because they cancel down. Pi over 3, remember, is 60 degrees. So 2 times cos of 60 is a half. So our gradient is in fact 1. So that's some exact values that you need to know there. Okay, so we've got our gradient. Do we have our AB? Because remember, equation of tangent is y minus b. We do not have our AB. But we do know that x is pi over 6, so we need to figure out y. We know that y is sine of 2x. Oops. So x is pi over 6. going to give us power of 3 like last time. Okay, sine of 60 is root 3 over 2. So we've actually got a point. Looks a bit, you know, unusual. But they're both just numbers, obviously. Right, so tangent. Y minus b. My days having a mare. Right, gradient we know is 1. AB's here. Going to just obviously get rid of that 1. What would you do next? You would add your root 3 over 2. Don't get too stressed about this. We're just leaving it in exact value form. Don't need to combine them. Don't need to worry about anything like that. You'll just leave it like that. Obviously, you could make that negative power of 6 plus root 3 over 2 a single fraction. I wouldn't bother unless the question specifically told you to. So that is your equation of a tangent involving chain rule. So anytime it's not just an x, it is something with the x, you need to think about chain rule at all times.